Welcome back to another day of the 12 Days of Christmas series. Today I will be creating a game where you repair Santa's sleigh. So let's first start with making the entire background. To Pygame, image, load, and it's going to be my sled background and convert. Alright, so I have my plate, my steel plate, and my tablet, which is just a black screen. And down in my while loop, I can blit every single one of those. So screen.blit my background at position 00, screen.blit my plate onto 100, window height divided by 2 minus 100, blit my tablet onto window width divided by 4, and window height divided by 2 minus 45. So this sets me up with this background pretty much, and this is where my sine waves are going to go. So let's start by drawing my template wave, which is going to be the one that I need to match. So I'm gonna make a new file called match, and here I'm gonna import Pygame. From math, import sine. From random, import randint because I need some random values. The constants, import all. And I'm gonna name my class match wave. Init method, no parameters. And here's gonna be some basic math terms. So I'm gonna have a self.amplitude be a random integer between 1 and 9. And I need a scalar. So I'm gonna say self scale and set it to 5. And now I can copy this and multiply it by that. Self.scale. And then I need a stretch. So self.stretch. It's also gonna be a random integer between 1 and 9 times scale. And then points. This is gonna be a list of coordinates that I'm going to use to draw a bunch of lines onto the screen using Pygame draw lines. So the way to get these points is by making a method that I call to calculate. And here I'm going to make a normal variable called points. And then for I in range of integer of my win width divided by 2, I'm going to append to my points list. So points.append. And here's where basically all the math is going into. So I want my sine wave to start at 1/4 of my screen. So I'm going to get I plus win width divided by 1/4. That's my X. And then the Y is the one that's going to be changing. So here's where the sine equation is going to come from. So I want sine of I divided by my stretch value. And then I want to multiply it afterwards by my amplitude. When you get sine of a value divided by stretch, it's going to grow horizontally. If I were to multiply it, it would shrink. And if I multiply the result of that sine, that is the amplitude, and that's how tall it becomes. And because this would start at the top of the screen, I do want to add at the very end my window height divided by 2 so that it does start at the center of the screen. Now that I have my points list, I want to return points, and now I can do self.calculate right here for my self.points. Now if we draw this onto my screen, Pygame draw lines, screen, head, and I'm going to input my points in here. I'm going to draw lines from at these coordinates. Let's do a pixel density of 3. So in our main, we can do from match, import match wave. Under our image imports, we can do match wave, make an instance of it. And at the very bottom, match wave.draw. Now if we run it, we can see we have a wave. And if I run it again, you can see that it's random. And it is a little hard to see like this. So what I did is draw lines, another black line right behind it, following the same points at the thickness of 7. Now if I run it again, you can see it's a little more defined. So let's make a second wave where it's actually manipulatable. And that will be the wave that we have to match with this one. All right, so I made a mistake. Let's rename this template wave and then rename the file template. Should still work as normal if done correctly. So now let's make a new file. This one will be the one called match. So really we can copy and paste our template wave in here. And the only difference is this one will be called the match wave. Scale in here will be an attribute, and I want the background line to be thickness 5 and color light gray. So if we go in here, from match, import match wave, we can call this the match wave, and down here match wave.draw, pass in the screen, Run this. Now we have 2 lines. This has to be blue. Now we have 2 lines from different colors. Here's the thing that we have to prepare for. We are going to be pressing keys in order to control the way our matching wave is looking like. So here I am going to separate the quit from the key down. So we are going to create a dictionary of Pygame key presses between 1 and 9 that would dictate how the wave looks. And that is why I was using randoms 1 through 9 here, because we're going to be pressing the numbers 1 through 9. And because the Pygame key presses are not literally 1 through 9, I have to make a dictionary for those keys that index whole numbers 1 through 9. So the way to do that is to start off by calling this selections dict and using Python's eval. And this will allow us to turn a string into some actual readable code. So I'm gonna make an f string, Pygame key I for I in range 1 through 9. And because 9 is exclusive, I'm gonna just add 1. And this will give us a dictionary ranging from K1 through 9 with a dictionary value from 1 through 9 as well. So we print this real quick. Here you go. 49.1, 52, all the way to 57.9. So now that we have a selection dict, we can start editing our match wave. So if we go in here on our key down area, if event key in range of Pygame key 1 and Pygame key 9 plus 1, we can say match wave. And here is where we're gonna have to make a new method in our match. So let's for now just make one called edit amp, and this will edit the amplitude. And what we need here is just a normal amp int parameter. So self.amplitude is equal to amp times self.scale. Same thing we did up here. And then self.points will need to be recalculated. Now we go back here, edit amp, and we say selections dict and index using events key. We can search through this, and if, let's say we press number 1. That's going to be this one. We're going to pass through number 1 and edit amp. Instead of a random number between 1 through 9, it will be exactly 1. The blue one is the one we're editing. If I press the number 1, you can see that it went super flat. And same with if I press to 1 through 9. You can see that the amplitude is changing, how tall it is. So now we need a way to kind of separate whether we're editing the amplitude or the stretch of it by using buttons that once pressed, flip the boolean and allow me to switch between edit modes. So let's start with making the button. Let's make a new Python file called button, import Pygame as PG, class button, and there are a couple parameters we need. We need a button image, a position, and a message. Self.surface will be Pygame transform scale, our image to 200 by 100. Self.rect will be self.surf.getRect. I'm going to set the mid top to our position, and then I want to import a font. So Pygame font, this font, let's use Comic Sans at size 42 pt. Let's make a self.text surface, so message with anti-aliasing, color black, self.text box, so our text surface rect. Now we want the center of it to be the center of our button rect. And then we want to outline color for some decoration and contrast. And we can set that to black. And the reason I also make this is not only for some contrast, but we are going to change it later once they're selected. So let's draw this. So let's start off by drawing the button. So rect, screen, self.outline color, self.rect.x -3, self.rect.y -3, and then self.rect.width +6, and then self.rect.h +6. And now we can draw our images in front of it. So screen.blitz, self.surf, self.rect, and then the text in front of that. So screen.blit, self.text, self.text box. So if I import this button from button, import button, I can go down here, make my amp button, and I'm going to pass in my plate image, the steel image that you saw right here. And that's going to be what the buttons are made of. I'm going to pass in my plate image, then the position I want it to be in. is window width divided by 3 and 25. And I want it to say amplitude on it. If I go down here, I can say amp button.draw onto my screen. I forgot some parentheses, so this is how it really should look like. Now, if I run it, you can see that I have my black outline with my plate image and it says amplitude on it. But I also need a stretch button. I'm going to pass in my plate as well. I'm going to say win width times 2/3 to go on the other side. Still 25. And I wanted to say stretch. Go down here, stretch button dot draw, run again. And I see the 2 buttons right there. And here's where the edit modes are going to happen. So in order to even select a button, I want to get my mouse input. Mouse input, Pygame, mouse, get pressed, and I want my mouse position. Pygame, mouse, get position. So down here, before all my drawing, I want to check if I just did a left click. And I want to check for collision. So if my amp button.rect collide point with my mouse position, I want my outline color to turn yellow. So if I go here and I press my amplitude, you can see it turn yellow. But now I need a way to turn it back to black. And simply just click the other button. Stretch button, rect, collide points, mouse position, stretch button dot outline color is yellow. Now if I just copy and paste this in here and turn it black, and then I get this line, go down here and turn this one black, you can see that now I can click these two and they will switch selections. Now in terms of edit mode, so beneath our main function, I want to create a tuple that are both set to false by default. I want my edit mode to be set to true and false, and then edit mode to be set to false true in the other. Nothing happening now, but we can use this to change whether we're editing the amplitude or the stretch. So in our match class, let's make a new function called edit stretch. Change the parameter name, change this, change that, and now we have the stretch method ready. And the way we're going to differentiate this is if the first one is set to true, because the first true happens when we're editing amp and we already have that ready, then we want to edit amp. Else if our edit mode second one is set to true, that means we're going to be editing stretch. So we want to grab all of this and then just say edit stretch instead. Once I press any button 1 through 9, nothing's happening because nothing is selected. They're both false. But the moment I select amplitude, I can now edit the amplitude. And the moment I select stretch, I can say how much I want it to stretch. However, the red one is not resetting once I found out what it was. So the easy way to do that is to have a method in both the match and template wave that return me their attributes. Give attribute, return self amplitude and self stretch. And I can just copy and paste this and put it in match as well. So if I go here, I can write if template wave dot give attribute is equal to match wave dot give attribute, then I want my template wave init method to trigger again. So now if I run it again, and once I press the number 8, it will change. So here's the new wave that I have to match. That seems to be the right stretch. I just got to change the amplitude. There you go. Change this downwards. Boom. All right, so that does it for today's game. Repair Santa's sleigh, and I will see you tomorrow.